at National Instruments, our product line is set up so that we can take advantage in our programming environment of multi-core processors. And so what we first did was we implemented a partial differential equation that was valuable to the financial engineering community. And we did that because partial differential equations are very compute intensive. And so what we really wanted to be able to do was show how our flagship product, LabVIEW, was capable of computing this differential equation and use an octal core, a 16-core system, standard Dell workstation. Once we did that and we were able to show the scalability, we realized that for larger problem sizes, we were not going to be able to deal with the large grid sizes that the financial community would want to deal with. And so what we ended up doing was looking at a GPU environment as a place to actually get more numeric computing power. So what I did in a part of my process was I took some of the co-workers that worked on the problem and developed the algorithm. I ported it to C++ to deal with double precision and single precision versions of the algorithm. I then ported it to C code to try and optimize it there. And then finally, in a day and a half, I took that same implementation and ported it to the video card. And voila, I ended up having a 60x performance improvement for grid sizes of 1K by 1K. It was absolutely easy. Over the course of about a week, I read the programming guide to get accustomed to doing it. I've been doing high performance algorithms in C and C++ for a number of years. I've been at NI for 14 years. We would normally take code in LabVIEW and take pieces of it and optimize it and call it in DLLs. So it's a rather natural extension to the development environment for us. So it's a very natural thing to do. And one of the things that I found that was very handy is the fact that when I generated the algorithm in C, the actual infrastructure of that algorithm, that the functions it deployed to the GPU as kernel function calls, would be the same blocks of code that I would also try and implement and make available in OpenMP. But I already realized the scalability wasn't there in terms of the number of cores that I had. So now I had one implementation of an algorithm out in C code that was perfectly viable for me to test against OpenMP and also deploy to the GPU device. Oh, I think as long as you know C code just at a rudimentary level, it's very, very easy to pick up CUDA. The extensions and the programming guide, they're all very, very straightforward. So it's really quite a simple thing to learn, and it's very effective. Like I say, I got a 60x improvement, and it was a course of a couple days, and I had never programmed in CUDA before.